All right, let's dive in. We're tackling MySQL replication logs today, and I gotta say, this stuff from Kedar is pretty fascinating.
Yeah, way more interesting than I initially thought.
Replication, keeping data consistent across multiple servers is, well, kind of crucial.
Oh, absolutely. Huge for so many applications. Think about like those massive websites or, apps that need to be up and running 24/7.
Right, replication, that's how they do it. So, where do these logs fit in?
Well, Keter starts with these things called binary logs, right?
Binary logs, okay.
And they're like basically a super detailed journal of every single change you make to your MySQL database.
Every change. So, like, every time I don't know, update a customer record.
Yep, every insert, update, delete, even changes to the database structure itself.
Whoa. So, like, if I add a column to a table, that gets logged too.
That's right, it's all tracked.
Hmm. So that means these binary logs are useful for more than just replication, right?
Absolutely. Kedar points out they're critical for point-in-time recovery.
Point-in-time recovery.
Yeah, like a time machine for your data. Imagine you, I don't know, accidentally delete something important.
Well, that's happened to me more than once.
Well, with these logs, you can go back and restore everything to how it was at a specific point in time.
That's pretty amazing. I'm already seeing why these logs are so cool. But let's get a little more specific. What exactly IOS is in a binary log entry?
Okay, so each entry includes a timestamp, so you know exactly when the change happened.
Makes sense.
And it also has the server ID, so you know where it happened.
Okay, so not just what changed, but when and where.
Exactly. And then there's, well, the actual change itself. That could be the full SQL statement.
The actual SQL.
Yeah, like update customers, set email.
Got it.
Or it could be like a row level modification, so just the specific values that changed within a row.
Huh. So different levels of detail depending on what happened.
Right. And then to keep everything in order, you've got position information within each entry.
So like the order things happened in.
Yeah, just like page numbers in a book. You got to know the sequence of events.
Okay, all this makes sense.
Mm.
But I mean, these logs can get pretty detailed, right?
No, they can get big.
So is there a way to control that? What if you don't need to log absolutely everything?
There is. Kedar talks about using system variables to customize how those binary logs work.
Oh, so you can like tweak the settings?
Yep, you can turn logging on or off, set a maximum size for the files,
Mm-hmm.
even decide how long they stick around before they're automatically purged.
Wow. So you can really fine tune it.
Hmm?
Cool.
But
Okay, but what about the format of these logs? Is it just a giant text file?
well, not exactly. Kedar mentions three main log file formats.
Okay, hit me with them.
You got statement, row to view, and mixed. And, which one's best? Well, it depends
On what?
on what you're looking for. They each have their advantages and disadvantages.
All right, let's unpack that. Starting with statement-based logging. What's that all about?
So with that one, you literally log the SQL statements that were executed. So like if you updated a customer's email address, the whole SQL UPDate statement would get written to the log.
Okay. Sounds straightforward. What's good about that?
Well, for one thing, you get smaller log files, especially if you've got operations affecting lots of rows.
Smaller is good, right?
Right.
Especially if you're dealing with tons of data.
Yeah, absolutely. Plus, since it's just recording the SQL, the logs are human readable.
Human readable. So I can actually like read and understand what's going on.
Yep, which can be super helpful for debugging.
Nice. Okay, but there's got to be a downside, right? There's always a catch.
Well, there are a few things to watch out for, like things called non-deterministic functions.
Non-deterministic
Yeah.
functions. Okay, you've lost me.
So these are functions that could like return different results each time you call them.
Give me an example.
So like the rand function in SQL, every time you call it, it generates a random number.
Oh, okay, I see.
So if you're replicating that statement, the primary server might generate one random number, but the replica generates a different one.
Ah, so things get out of sync.
Exactly. And there are a few other things that can cause issues with statement-based logging, like certain operations that need special handling.
Okay, I'm starting to see the limitations.
And sometimes functions might replicate differently on different server versions.
Tricky. So statement-based logging, it's good for like simple operations, right? And when you want those smaller log files,
Yep, great for bulk updates and schema changes, things like that.
but maybe not ideal for the more complex stuff.
Right, and that's where row-based logging comes in. So with row-based logging, instead of the whole SQL statement, you're logging the actual changes to the individual rows.
Okay, so if I update that customer's email address, the binary log doesn't show the update statement.
Right, it'll show something like, in the customers table row with ID 123, the email column changed from this to that.
Wow, that's pretty detailed.
It is.
But I bet those log files get huge EE,
Yeah, they can be bigger.
especially if you've got lots of updates and inserts going on.
Definitely. But you get a big advantage in return.
Reliability.
Reliability,
All
okay.
right.
Because you're capturing the actual data changes, so you don't have to worry about those inconsistencies that can pop up with statement-based logging, especially with those non-deterministic functions.
Right, those random number things. So row W-based logging, that's the best way to make sure your data stays consistent then.
It's a strong choice, especially for like financial applications, situations where even a tiny discrepancy could be a big problem.
Yeah, that makes sense. But, you mentioned the larger log files. Doesn't that impact performance?
It can. Kedar points out that if you have tons of write operations, those big log files can put a strain on your system.
So it's a trade-off, reliability versus performance.
Right. Gonna find that balance. But hey, MySQL gives us a third option, mixed logging.
Mixed logging, what's that? Some kind of hybrid?
Exactly. It uses statement-based logging as the default.
Which is efficient, right?
Yep.
But then it switches to RW-based logging when it needs to.
When it needs to. How does it know?
Well, there are built-in rules, like if you've got a transaction with a non-deterministic function, it'll automatically switch to RW-based.
Ah, that's pretty smart. Gets the best of both worlds.
Right. So we've covered binary logs on the primary server. Now let's look at how those changes get over to the replica.
Okay, so we're moving the data.
Yep. Kiar takes us to the relay logs.
Relay logs.
Think of them as temporary copies of the binary log events. They sit on the replica, waiting to be applied.
So like a staging area.
Exactly. And just like binary logs, they've got their own structure, files, an index file, an info file.
Sounds organized. But if they're temporary, do they stick around forever?
Nah, once the changes are applied, they're purged automatically.
Efficient.
Yeah.
Okay, but how does the actual data transfer happen? Like from binary log to relay log?
This is where the magic happens. We've got two key players here,
Hmm.
the IO thread and the SQL thread.
Threads.
Yeah, these are the workhorses of replication. Okay, so walk me through it.
So on the replica server, you've got the IO thread. It connects to the primary server, reads those binary log events, and writes them to the relay logs.
So it's like constantly pulling the changes over.
Yep, like a dedicated messenger, handles all the network communication and stuff.
Okay, then what?
Then the SQL thread steps in, reads from the relay logs, and applies those changes to the replica database.
So it's not just copying and pasting. It's like actually making those changes happen on the replica.
Yeah, exactly. And it does it in the right order, too.
To keep things consistent.
Right. It even handles any errors that pop up.
Wow, it's a whole, choreographed dance.
It is. And if you break it down step by step, it all makes sense.
So to make sure I've got this straight,
What?
we have the primary server doing its thing, writing to the binary log.
Yep.
Then the replica asks for those changes.
Right.
The IO thread grabs them, brings them to the relay log.
Huh?
And finally, the SQL thread applies the changes to the replica database.
Boom. Data synchronized.
Pretty incredible. But one last question. What happens after the SQL thread applies the changes?
Well, remember those relay logs are temporary,
Yeah,
so
yeah.
they get purged.
Gone. Okay, but what if something goes wrong during that process, like an error while applying a change?
Good question. That's where the SQL thread shines. If there is an error, it stops, logs it, and waits for someone to fix it.
So like a safety net.
Exactly. That's why understanding this whole process is so important.
Yeah, if you're troubleshooting, you know where to look.
Right, in the logs. And Kedar also talks about the bigger picture, like why understanding these logs is so important in today's world.
Okay, I'm all ears. Why should we care about these logs? Beyond the technical stuff. So the why of it all. Why are these logs so important? Big picture.
Well, think about just the sheer amount of data out there these days. Websites, apps, research,
Yeah.
everything runs on data.
Yeah, and that data has got to be available all the time.
Right, downtime, no way. Replication is key to making sure that happens.
So even if one server crashes, the data is still there on the others.
Exactly. And knowing about these logs, that's how you manage and, troubleshoot that whole system.
If something breaks, you can fix it.
You got it. And Kedar talks about how you can actually use this knowledge to fine-tune your setup.
Tweak it for better performance.
Yep. Those system variables we talked about. You can control log formats, sizes, even how they get purged.
So you can really optimize it for your needs.
Right. And then there's the security side of things.
Security?
Yeah. Kedar mentions how these logs are like a full audit trail of everything that happens in the database.
Oh, because it's all logged. so you can see who made what changes and when.
Exactly. Super important for, compliance and stuff.
Right. Like if you need to prove that certain data was handled correctly.
Yep. And also, if there's like a security breach, you can use these logs to investigate what happened.
See if any data was tampered with. Man, this has been eye-opening. I thought these logs were just like a technical detail.
Me too. But it turns out they connect to so much more.
Like data management, security,
Yeah.
even keeping your business running.
It all comes back to those logs.
Big thanks to Kedar for taking us through all of this, and to you for listening. We hope this deep dive has given you a new appreciation for the power of these MySQL replication logs.
Yeah, it's been fun.
And before we go, here's something to think about. We've seen how replication helps keep our data safe and sound. But what about the future? Data is exploding everywhere. What new challenges will we face? And what new tools will we need to handle it all? We'll have to keep exploring that.